So my session today is Principles of Microsoft Silverlight Graphics and Animation, and what the intention of the session is to give you kind of a high-level overview of the graphics and animation subsystems that are available to you in Silverlight. My name's Jeff Perrys. I'm lead experience developer with Wagner Edstrom Worldwide. I'm also the author of 2 books on Silverlight, Foundation Silverlight 2 Animation and Foundation Silverlight 3 Animation. The next slide in the presentation is my favorite. It's my shameless plug where I get to show you what the cover of my book looks like and some of the kind reviews I got off of Amazon.com. A lot of the content that I'm going to be covering today goes into a whole lot more detail in the book. Since I only have an hour here, I don't have the opportunity to go into great depth on any one topic in particular. The topics I'm going to be covering today, I'm going to start with graphics for Silverlight, and I'm going to talk about what's supported, where the graphics come from, and what the runtime will do with them. Declarative animation in the context of XAML. And XAML, in case you're not familiar with it, is the extensible application markup language that defines a UI in Silverlight. I'm going to be showing that in the context of Blend, and I'm actually using Blend 4. Most of the stuff that I'm showing is relevant for the beta. And then we're going to start digging into procedural animation in C#. I promised myself a long time ago I would never code anything in front of anybody, so I will show you some code, but I'm not going to be doing it live. We're going to talk about vectors, particle systems, frame-based animations, and kinematics. And again, the idea here is to give you a high-level look at some of the things that we can do with animation in Silverlight. So let's jump into the graphics. Within Blend, Silverlight, both vector and raster assets are supported. Specifically with regard to raster, you have Photoshop import in Blend, JPEG, and PNG 8 and 24-bit. On the vector side, you have the option to import Illustrator, as well as use the XAML shape class to draw ellipses, lines, paths, and make your own artwork. And one thing I wanted to show, a lot of the PSD and Illustrator import talk, you don't see a whole lot of examples of that. And I do have one here that I wanted to show you. Basically, when you're doing an import, you would come into Blend and do a file import, either Photoshop or Illustrator file. This is actually an Illustrator file that you're looking at. It's a true vector format. You can see the list of the paths that I have down here on the left, and there's a couple of images that were used for highlights. You have an option of having artists create these for you. There are libraries that you can find online to get them, so you're not stuck to just JPEGs and PNGs. But I just wanted to show a little richer example of what you can do with a vector import. It's that particular file, something to keep in mind there, that file is over 8,000 lines of XAML, so it takes a little bit to open and would be a little bit, it would be a little bit of work to manipulate, but just so you have some idea what you can do with it. So if these are the kind of images that we can use with Silverlight, we need to talk a little bit about what we can do with them. When you actually create your application, you have the option of compiling them up within the DLL as a resource in your application. You can compile them with the application package, which is referred to as a ZAP. If anybody doesn't know this, it's a renamed zip file. You can put them outside the application package, local on the same server, or you have the option of hosting them on an external website. But be aware of the fact that you may run into cross-domain restrictions. If you're trying to access an image on another server that somebody wants to block or doesn't want you to take, you're not going to get the option to take that without a cross-domain policy. So we know what kind of images we can use. We know where we can put them. We can take a look at a project in Blend and start digging into storyboards a little bit to start seeing how the animation system works within Blend. This is, just assume that I've created a new project here. I just have a basic canvas layout object, and then my sun object is on top of that. Many of you are probably familiar with storyboards already. This is just going to be a little bit of an overview. And the next few topics that I'm going to talk about, what I'm trying to show you is the work that you're doing on the artboard here or in the timeline. Blend is doing work for you behind the scenes, and I'm going to show you what that looks like so you can understand how everything goes together. So the first thing I'm going to do if I want to create a storyboard in Blend is I'm going to come down here on the Objects and Timeline panel, and I'm going to click the Make New Storyboard button. I'm going to get a dialog that says Create Storyboard Resource. I have an option of putting a name in here. In this case, I'm just going to stick with the default and click OK. And what you're going to see is that the interface of Blend has changed. Basically, I get access to a timeline, and you'll see the red border around the artboard basically indicates that I'm in a timeline recording mode. Now, anything I do in the interface is recorded and is going to become part of my storyboard. So you can see the changes in the interface in Blend, but what just happened? It obviously did something. And the net result of the action that I just took is that I created this storyboard, the line of code that you see across the top there. This is an empty storyboard named Storyboard 1. If I were to continue working, as we'll do in a moment, you'll see that Blend will populate the storyboard for me. You can see that this is a self-closing container, and the reason why I put that reference down there on the bottom is it might be just a little bit easier for somebody to visually distinguish the equivalency on the storyboard container there. The storyboards have a lot of properties that can be changed. You have access to properties such as repeat behavior, duration, speed ratio, and generally the important thing that you want to take away from what you're looking at right now is that a storyboard is a container. This one right now is empty, and we're going to put some content into it. So storyboards are containers. They can contain one or many animations. You also have the option of leaving them empty and using them as a timer. I'll show you more about what the timers can do for you when we start digging into procedural animation a little bit. In this particular case, I'm showing you an empty storyboard here, or a timer storyboard with a duration of 0 called move. The other option you have is if you're a hardcore developer, you prefer working only in Visual Studio, you can create storyboards completely from code. So let's jump back over to Blend. I'm working with my same project here. What I want to do is start talking about animations. So my storyboard is a container. Inside of my storyboard goes an animation. In order to create an animation in Blend, the first thing I'm going to do is grab my timeline playhead, and I'm going to move it at some point down the timeline. In this case, I'm going to create an animation that's 1 second long. The next thing I'm going to do is grab my object on the artboard and move it. And what you'll see is that Blend has inserted a marker on the keyframe, on the timeline for me to indicate that I've got a keyframe or an animation placed in there. And much like with the storyboards, Blend is working behind the scenes for me. And in this case, this is the chunk of code that got inserted there. This is what's considered a simple 2-type animation. We'll talk about the types of animation in a minute. But what you can see here is across the first line, it says double animation duration equals 1. That's the 1 second where I move the timeline playhead. The 2 is the value that I'm animating to. The important, really important 2 parts of this are the storyboard target property, which if you read that all the way to the end, you'll see translate x, which is indicating that I'm moving my object only along the x-axis. And the target name is sun. That's which object I'm targeting. So animations, I'm going to show you some examples of this in a minute, but I'm actually going to cover quite a bit of detail on the storyboard, so I have to kind of keep rolling through some of the details here. Animations are placed inside of storyboard containers. They also are containers, and they contain keyframes. Animations are used to change object properties over time. And something to keep in mind is that the types of animation that are available to you correspond to the data types that you're working with in C# or Blend. So you have a double, which might be an example of like a width and a height or left or top properties on an object. You have color animations that are used to modify fill colors or stroke colors. You have the option of doing point animation to modify paths that make up vector graphics. And then there's an object animation type that's used to flip the visibility flag on an object. And I'll show you what we can do to take advantage of that in just a bit as well. So, and much like storyboards, animations can also be created from code. So moving along, there's 2 different variations on animations. Each animation has 2. There's a from to type, which is what you just saw. And that's a very simple animation. If I went in and did another move on that object, it would automatically switch to the using keyframes type. The using keyframes type of animation is what people typically expect when you hear the word animation. You're going to move an object over a series of, over a period of time in order to create a series of keyframes. And when it's played back, it's going to create the motion for you. So you've seen storyboards. Storyboards are containers. They contain animations. You know animations are containers. And inside of animations go keyframes. And there are 4 types of keyframes that are available to you in Silverlight. A lot of this stuff you don't have to worry about because Blend takes care of it, but it's important to set the context of what's going on for you behind the scenes here. The 4 types are linear, spline, easing, and discrete. A linear keyframe is not something that Blend has ever created on its own, but it's available to you in declarative animation. You can go in and type it in if you want to use it. Spline type animation allows you some basic motion easing. You can get objects to accelerate or decelerate as they're coming into or leaving keyframes. The easing spline is now the default type, and I'll show you the reason for that in a moment. That gives you access to a bunch of easing functions where you can produce bouncing or elastic type behavior as your objects are approaching keyframes. And then there is finally a discrete keyframe type. And this keyframe holds an object in one position until the next keyframe is reached, and then the object immediately jumps to the other. So if you want to change the type of keyframe that you're using, you saw on Blend where it created the small oval on the timeline when I started creating my animations. Each keyframe would have a small oval. If I click that oval, there's an easing pane on Blend that will open up, and you'll see there's kind of 3 little tabs across the top there that say key spline, easing function, and hold in. If you click the key spline type, it will change your keyframe to a spline, an easing spline. Sorry. A spline type. If you pick the easing type, you'll get an easing function. And if you're picking discrete, or if you're picking hold in, you'll get a discrete keyframe. So if you are looking at the XAML for each of these, basically a linear double keyframe looks like what you're seeing up here. I'm using the same values I had in my animation that we were just taking a look at. Key time is 1 second. My value is 480. The target properties and stuff are omitted here, but this is at the keyframe level, so the target properties are handled up at the animation level. A spline double keyframe, these two have the exact equivalent behavior because there is no key spline property attached to the spline double keyframe. I'll show you examples of these again in just a moment. And here is a spline double keyframe that includes the key spline property. This gives me some basic easing as I'm approaching and exiting keyframes. The easing function keyframe looks like this, and basically what it does is call out, in this case I'm using a bounce ease, and I'm easing in and out of the keyframes. And then the last type is a discrete double keyframe. So you can see when you're declaring all these in XAML, they all look pretty similar. A lot of this code gets written for you by Blend. And I realize that a lot of what you're seeing here is probably, or the information that I'm sharing here is probably really overwhelming. It's probably a little bit easier to see an example. So I have a couple demos here, and I'll show you that will probably kind of help put it in context a little better for you. Basically, this example, I have a application that has 5 animations in it, one of each type of the radio button that you see up there. The animations are all exactly 4 seconds long. Each one has a keyframe at 1 second intervals, so 1, 2, 3, and 4. And what I'm trying to illustrate to you here is the difference in the types of motion you get by using the different types of keyframes. So if I'm using a linear keyframe, basically what you're seeing is a very linear motion. It moves like you would expect from the name, from keyframe to keyframe. If I select a basic spline without any easing on it, you get the exact same motion. So this is what I was referring to a moment ago where I said basically the spline and the linear keyframe give you the exact same motion. If I use a spline type and I put basic easing on it, this is where the motion starts getting a little bit more organic. Now you see that my object is accelerating out of the keyframe and decelerating as it's approaching the next one. The next one here uses an easing function called elastic, and it's using the elastic on the entry into the keyframe. And you can see it gives a little bit of a, it makes it look like the object's attached a little bit to a piece of elastic. And you have a lot of control over these functions on the easing pane inside of Blend, so there's quite a bit you can do with them. And then finally is the discrete type, which if you recall will hold an object at one keyframe until the next keyframe is reached, and then it jumps over. So these are really basic examples, but you can do a whole lot more with storyboards than what I'm showing here. This is really just intended to be a quick overview. And so what I wanted to do really quick was just show a couple of projects I had the opportunity to work on. This one here is Models Remixed. It's in support of the Microsoft Oslo application development platform. This particular application contains roughly 5,400 lines of XAML code to define the UI. 3,500 of that is what creates the storyboards. And the storyboards that I'm trying to illustrate here are the ones that run the branches for the menu. So if I pick something here, you'll see the menus kind of collapse. The parts move around. If I return back out, they'll come back out. The way this was built is it was laid out like you see here and animated in reverse. And then I have the option in Blend of doing a duplicate and reverse storyboard. I had to do a little bit of tweaking to clean it up. This particular animation, by illustrating the point that there's 3,500 lines of XAML for the storyboards here, is probably not something you would want to approach as a procedural animation. And then the other example I have is an application that I worked on that basically illustrates the obesity epidemic in the United States. It's a data visualization that shows the obesity rates in the US over the past 20 years. You have the option up here. It's actually kind of disturbing if you grab the little slider and move back here and see how drastically it changes. There's two sets of from-to storyboards that are driving this particular set of data visualizations here. The important parts to hit are under the arrange and by. If I do ascending or descending, you'll see that the objects will rearrange themselves. And then my other option is to go by obesity rate, where they're all, I have the data on the back end, we're rating, updating the to field of the animation, and then starting the animations. And you get kind of a nice look on it, and it's two sets of storyboards. One handles the ordering by, the other one handles the arrangement. This information, this particular project, if you're interested in taking a look at how it was done, is up on the Describe Mix Online labs. And so the next thing I want to talk about, that kind of covers where I wanted to go for the declarative animation. And the next stuff we're going to start digging into is procedural animation. And I showed some basic storyboards. I showed some kind of interesting examples that you can do with more complex storyboards. And you might start thinking, well, if I could do nice looking animations with storyboards, then why would I ever want to bother going through the trouble of doing it from code? The cool thing about code-based animations is that you add a whole new level of interactivity to your application. You have a different ability to draw people in. You can start emulating the physical world. The difference here is that every time I go to one of these sites, my experience is going to be the same. The storyboards are the same. They're going to run the same. They're going to treat the little tiles the same every time I run it. Procedural animation gives me the opportunity to kind of break out of that. And the basis for procedural animation is vector and vector movement. So vectors are basically a key component of procedural animation. They give you a way to describe direction and distance independent of time. And that's important depending on how fast you want your objects to move, how fast you're passing time in your application. A vector movement really is actually pretty simple. For each unit of time that passes in your application, you may add one or both of your vector components to the object's XY position. And I have an example of that. We'll start out with a one-dimensional vector movement. Just assume that I created a project here. My layout root is a canvas object because it gives me absolute positioning of objects rather than relative margins that you get with grids and some of the other layout containers. The origin is at the top left, 0, 0. Positive x-axis moves out to the right, and the positive y-axis is down. So if I want to assume an x velocity of 1 on an object, and I'll put my ball up here on the screen, what I'm going to do is use a storyboard with a duration of 0, just like the one that I showed you a little bit earlier, and I'm going to attach an event listener to the completed event of the storyboard. So I'm going to start the storyboard, and because the duration is 0, it's going to expire immediately and raise the event, which is going to drop me into an event handler, where I'm going to take my object's position and add 1 to it, and it's going to move. The last thing I do in that event handler is restart my timer. It's going to expire again because it has a duration of 0, and my object's going to move. And that's how you create the motion on it. Two-dimensional vector movement works the exact same way. And in this case, if I assume an x velocity of 1 and y velocity of -2, the thing you want to note about the -2 velocity is because the positive y-axis is down, it's going to move it up the screen by subtracting from the y value. In this case, if I start my storyboard, again, the duration is 0. The storyboard ends. I add my vector components to my object's location, and I'm going to get that same movement, restart my storyboard again. And the process ends up animating my object across the canvas. So one of the really cool things about the vector movement is because it's so simple, it's actually really easy to kind of manipulate what's going on with the objects when it's running. For example, if you're getting to a point where you have a bunch of objects and there's a lot of interesting motion happening in your screen, eventually you're going to want things to start bouncing off of boundaries or objects inside of your application. In this case, if we assume that the blue bar here is a border that I want to reflect an object off of, all you have to do to reverse the direction of a vector is multiply the appropriate component by -1. So if we assume a 45-degree angle here is a vector of 5 minus 5 is actually pretty quick motion. As soon as I realize that my object has encountered the border, if I multiply the y component of my vector by -1, I'll end up reflecting the object off at the exact angle that it hit the object. So I'll get a resulting vector of 5, 5. A lot of the examples here that I have utilize this as basic boundary code to reverse direction on objects. If you want to see what the actual code looks like, using vectors in C# is actually pretty simple. You start by creating and assigning your variables. It's pretty simple. There's a point that maintains the object position, and then I'm using 2 doubles to contain the velocity values. In this case, these are the same ones that I was using in the example 1 and -2. This is what the completed event handler stub would look like for my move completed event when my storyboard fired and raised the completed event. Inside of that, this is all the code I need to animate an object with vectors. The object position.x and object position.y are incremented by the velocity x and y values, and then I do a set left and set top on my object to update its location. Now, much like changing direction, since the vectors are pretty accessible and pretty easy to work with, if I wanted to add a little bit of gravity into this particular model, all I have to do is add a line of code that increments my y velocity by some gravity value. And the last thing that I need to make sure that I remember to do in this particular event handler is restart my storyboard so that I keep the motion going. So let me show you an example of this technique in action within an application. Basically what I have here is a ball that just has a basic drag and drop code applied to it, but if I throw it, this is all vector motion, basically the same code you were just looking at that's running this particular animation. Yeah. And what I've done is attach the gravity value to a slider, so if I wanted to, I could come in here and make the ball kind of float a little bit. And so it's pretty live. It's a little bit more interactive than what you were seeing with the storyboards. It's a little bit more fun to play with. So the ball drop's a really good example of this. There's actually a far more common example that you're going to see where vector motion is used, and that's particle systems. So I want to go ahead and dig into particle systems a little bit. Particle systems are often used to model fuzzy objects like fire, smoke, explosions, and water. By a fuzzy object, I mean something that doesn't really have a well-defined edge. You have the option of getting kind of loose edges on particle systems depending on how they're built. The basic model for a particle system, whether it's in, a lot of times where you see them is in a 3D modeling application used in the movies a lot for water and fire. Whether it's in 3D or something that you're doing within Silverlight, particle system model is pretty much the same. As time is passing in your application, each tick of the clock, whatever your timing may be, you might be creating new particles based on some count that you're trying to keep track of. Old particles will be conditionally removed. This is if you're keeping track of a lifespan or age on each particle. And existing particle positions within the system are going to be updated to keep them moving around the screen. A method example for move particles, if I'm going to show you, here's a stub for move particles. This would be the equivalent of what would be called when a storyboard ended. In this particular case, I'm wrapping my code inside of a for loop. You'll see particles.count listed there. Particles is a list of type particle. In this case, my particle is just a series of an ellipse that I'm working with. And for each particle, basically what I'm doing is running a set left and set top. The code that you're looking at right here is identical in functionality to the 4 lines you saw before. I've just condensed it into 2. So basically I'm doing a set on the particle, the currently selected particle object, get left and get top is the current position, and then I add the velocity x and y to it to keep it moving. The last thing, again, that I need to make sure that I remember to do here is to restart my storyboard to keep the motion going within the system. So there's a lot of code that you're not seeing here. I would include code for creating particles. My variable definitions up at the top are not there. If I was keeping track of a lifespan or an age on an object, that would be inside of my for loop, is where I would be aging it. Outside of the for loop, just before I restart the timer, is where I would be evaluating that age and acting if I wanted to remove particles from the system. But basically what you're looking at here, this little handful of lines of code is enough to drive a basic particle system. So here's an example of one that's running. This is non-hardware accelerated. It's running 750 particles, I believe, of varying sizes and velocities. It's kind of fun to look at. It's kind of interesting. Every now and again, the particles condense into a little bar, either horizontally or vertically. There they go again. So one of the things that's kind of interesting about particle systems is how you can approach them in a way that's going to make them interesting to an end user or whatever it is in the system that you're using. Obviously, if it's part of a game, there's going to be some interest in that by default. But generally speaking, if you're building a particle system for the sake of building a particle system, you have the opportunity to randomize a lot of the parameters in there. In the case of the one that you were just looking at, I have the option of randomizing colors, size. I didn't utilize lifespans, but I could assign that relatively easily, and then the velocities. Another option I have is to add some secondary animation to the particle system. That is, as a particle is moving via vector movement, you can also apply a storyboard to it to get some secondary action on it. I can let my user modify the system through a variety of sliders or other input methods. And then the last thing I could do would be to use emitters. Particle emitters, generally the system you just saw, it randomly distributes particles on the layout root canvas. An emitter gives me a way to produce particles at a different or moving location inside the application. What a particle emitter actually does is give me the opportunity to define the shape or area of a system. Typically, you would come across either a point or a rectangle. It would probably be somewhat processor intensive to try and calculate circles to generate particles out of it. I'm not sure that you would get a lot of return on the investment. Particle emitters can be animated. You can use a mouse position. You can move objects on the screen and generate particles from those positions. And it's actually pretty simple to implement an emitter. Basically, all you have to do is name your emitter object so you have access to it easily from C# or VB if you happen to prefer that, and then generate the particles based on the emitter location. So I have a couple of examples to show you of particle systems that use emitters. And the first one is a comet. So what this particle system is doing, the emitter is actually the comet piece that's moving in an ellipse. The comet is actually animated entirely procedurally. There is no storyboard. And then as my particle system is running, the particles are being generated based on the location of the comet at any given time. This one also uses secondary animation. I don't know if it's really visible on the screen up there, but you can see that they kind of shimmer or sparkle a little bit. They have kind of a blinking animation as they're dropping. So as each particle is generated, I start that animation. It's set to loop forever. And then as the particles drop off at a given age, they are removed from the system. The next example I have is a emitter-based fountain. And this one is a good example of what I can do to give user input on a system. If you notice up on the top left-hand corner, what you're looking at is the particle count. And this is essentially generating particles out of a single point. So I put a couple of sliders on here to offer some control. I have the ability to spread out the way that the particles are being generated. I can go all the way down to a single stream if I wanted. I have the ability to force them out faster or drop down the speed at which they're being emitted. I can alter my gravity value. And then lastly, I also allowed the opportunity to change the number of particles. And you can see what happens is that because I have it inside of a expiring storyboard timer, that the number builds up slowly rather than an immediate change. You wouldn't see a burst of particles appear up inside the fountain. So you've got an opportunity to take a look at a basic particle system. We talked a little bit about how to make a particle system interesting to look at and a little bit about particle emitters. And I'm going to wrap up today talking about another interesting technique that can be used to create particles and particle systems, and that's the writable bitmap that became available in Silverlight 3. The writable bitmap class actually lets you do a lot of really cool things with bitmaps in Silverlight. Specifically for particle systems, what we like about it is that you have pixel level access to bitmaps and you have the ability to generate images on the fly. The class that I use is called Blit Writable Bitmap. It was created by Bill Reese, and it allows me blitting and blending of the images that I'm putting inside my particle system. When I talk about blitting, blit stands for block image transfer. What it is a method that allows me to combine multiple bitmaps and elements into a single image. And in this particular example, if I had 3 different ellipses in my application, it really doesn't matter if these are XAML assets or a PNG or JPEG or something that you've added. You can insert or blit in either case. And I have a destination image element. So I would take those 3 objects and blit them into the existing image element. What this does is basically create a bitmap that is live and running as my application runs. The other nice thing about this, the blit option, is that I have a lot of control over the location of the individual bitmaps that I'm blitting. If I wanted the red one to be smaller, if I give it a smaller destination rectangle, the blitted image will scale down to fit in there. The code to do this is actually pretty basic once you have the library added to your project. This is a explicit definition here to kind of aid my explanation. I have the image that I'm going to write to, so I'm going to call that image to write. I'm going to call the blit method. And what I'm going to pass it is a destination rectangle, which is where I want my object to go into the new image, a writable bitmap type source image, a source rectangle, which means which part of the source image do I want to take. I can take the whole thing or crop out just a part if I'd like, and then a blending mode. The actual code for implementing something like this would probably look something along the lines of this, although you may not define your rectangles within the method call. So in this case, my destination rectangle is a rectangle that is 150 by 100, or is positioned at 150 by 100 and is 100 pixels wide and tall. WBMP2, writable bitmap 2, is my source image. And I'm going to take that entire image, so you can see the rectangle I'm creating there, 0, 0, 100, 100. And then finally, I'm passing a blend mode additive. So the blend modes that are available to you give you a little bit of control over what the destination image looks like. There are 4 types that are available to you. The first one is none. If I have an image, say for example I'm using a series of ellipses like you see here that are inside of Silverlight, typically you may not have the background rectangle that contains them full of color. If you blit them into a target bitmap, they will be given a background color if you don't pick the type alpha. So alpha, this particular example, is probably what you're more accustomed to seeing when you're working inside a Silverlight. The third type, and where it comes into particle systems and makes particle systems fun, is additive, because this is where the images are overlaid and it starts adding the color values together. So in this case, you can see in the center I'm getting a little bit of a white hotspot. There's yellow where the red and green cross, purple over on the blue and red side. The final type that's available to you is subtractive, and that is an exact inverse of what the additive type is. And I have 2 example particle systems to show you. The first one I asked Bill, and he kindly allowed me to use. This one uses an emitter to generate a writable bitmap particle system that has 150 particles. So what you can see on this one as it's running is you notice the particles as they travel out from the emitter start to fade. This is because they have a lifespan attached to them. You can see that they're cycling through colors as they're running, and that they're following the mouse as I move the mouse around. So keep in mind what you're looking at here. This application is 800 by 600 pixels wide. The entire application is being rewritten as fast as you're seeing the animation going here. I think the time, I don't have my frame counter turned on this one. I think my frame rates were around 60 frames a second on the redraw here. And then the last one that I have to show is an example that I created in about 30 or 45 minutes. I talked a little bit about how particle systems are used to create things like fire and smoke. So here's a little bit of an example of a flame. You can see it has a little bit of a oscillation in it as the particles are rising up and passing through their lifespan and disappearing as they reach the top of the system. Each one of these systems is also 150 particles, so what you're looking at here is about 600 particles running. So that wraps up what I wanted to cover on particles, and the next animation we're going to take a look at is frame-based animation. Frame-based animation is actually intended to kind of imitate the original flipbook technique, and in case anybody isn't familiar with that, I have an application that'll kind of illustrate that for me. Basically what you're going to do is take a series of images and you want to find a way to run through them fast enough to give the illusion of motion. So what I'm going to do is go ahead and accelerate this film strip, and it'll take a few seconds, but what you'll see is eventually it'll get going fast enough and persistence of vision will kick in and you'll get the illusion of motion here. And this is actually running this fast. It's not any kind of a trick or anything. It's not a video piece. So there you go. There's a series of images that are being flipped through fast enough to illustrate motion. While the examples I'm going to show you aren't as literal as a film strip laid out horizontally, there are some techniques that we kind of take away from that. The nice thing about frame-based animation is there's a variety of ways that you can do it. If you prefer doing it from code, you can do it from code. You can use storyboards, or you can leverage the visual state manager that's available inside of Blend. Complex frame-based animations, if you're thinking about doing game design, is probably something you want to spend a little bit of time thinking about. There's a thing called a movement flowchart that charts out all of the movements of your objects or character. And if you're doing very complex animation, it's important to think about how you're going to get maybe from a walk to a run or do a punch motion or something like that without a jarring movement between the objects. So the most common way that you would think of a frame-based animation is in the context of probably a game sprite. Inside of a game, pretty much anything can be considered a game, but for the purposes of my discussion, I'm going to say that a sprite is a 2D or 3D image or animation that becomes part of a larger scene. They were first used in the mid-'70s. They're still in use today. Otherwise, I wouldn't be talking about them. And there are quite a few different methods available to you to produce sprite content. You have the option of rotoscoping live video. You can take the individual frames like I showed on the film strip. Claymation is an option. If anybody's familiar with the original Mortal Kombat game, one of the characters in there was done with stop-motion claymation. You can use 3D software, which is the method that will be shown in the examples that I'm going to show here, to generate images either as 24-bit or if you want to have a background color in there and deal with that however you want to deal with it inside the application. Finally would be vector artwork to have somebody draw a series of frames for you. So let's take a look at how we go about creating some sprites. The first way that I want to show you is to do it with discrete keyframes. If you remember when I talked about discrete keyframes, they hold an object at one position until you reach the next keyframe, and then they immediately snap to the new keyframe. So what I want is a series of images that depict my desired action. I'm going to align the images either horizontally or vertically. And in the example I'm going to show you, I'm going to use horizontal. And then I'm going to translate those images at some interval. And what I'm saying is that if I have an image or a series of images, as my storyboard is running, I'm going to move them either left or right at some interval, the interval being whatever my storyboard is running at. So in this particular example, you're looking at Blend. This is a project. These frames are 720 by 480, and I have a series of images of a dog walking. If you look over on the left-hand side in the Objects and Timeline panel, what you can see is the series of images. It's 13 images. They're inside of a container. This may be hard for people in the back to see, but they're inside of a container called Dog Poses, which is what's actually highlighted in blue on the artboard at the moment. Typically, I would apply a clipping path to that so that you can't see anything outside of it, but just for illustrating my point here, I left them visible today. This is what the actual storyboard that runs the animation looks like. And basically what it is every 1/10 of a second, you can see that I have an X translation applied, and it's moving the entire series of images inside the canvas 720 pixels to the left. So let's go ahead and take a look at what this example looks like when it runs. And what I have is initially this is set up very slow, so you can see the way that the motion is going on it. I put a frame counter up on the top left just so you could track the way that it's actually moving through the frames. The way I'm controlling the speed on this one is a slider that's attached to the speed ratio value or property of my storyboard. And so if I come in here and bump this up a little bit, basically what you're going to see is I'm getting a smooth motion on this. And this, again, is translating these 720 by 480 images at a relatively high rate of speed. On this particular one, if you look down in the bottom left-hand corner of my status bar, you'll see that I'm running at about 14 frames a second. And you can see the faster it goes, my frame rate oscillates a little bit up in there. So as I mentioned earlier, discrete keyframes are just one of several methods I could be using to create frame-based animations. Another option that I have available to me is object animation, which if you recall earlier, I mentioned controls the visibility of an object. So if I'm going to do a sprite with visibility, basically I'm going to take a series of images, add them into XAML, and in this case they're going to be piled on top of one another rather than spread out horizontally. And I'm going to use a storyboard to flip through the frames in series. So if I'm looking at my container, in this case I have a series of images that represents a walk cycle for a 3D Space Marine character. The images here, I have 23 inside of this container. And my storyboard for that, if I'm working inside a Blend, looks a little bit different. You can see it's a little bit stair-stepped, and in this case I'm having to touch each one of the images at some interval to turn off. The image starts being on, it's turned off, and then the next one in the sequence is turned on through the visibility flag. So the end result of the animation in this case is something that looks like this. And you can see in this case, this one is running actually at 62 frames a second. So I'm getting pretty good throughput using the visibility flag here. The third way that I have, not using code, but the third way that I have within the context of Blend of creating a frame-based animation is the Visual State Manager. So I have a third example here that I'm not going to go into detail about how I did it because the animation techniques are pretty much the same. But I'm using the Visual State Manager, and in this case I have a character that I created 3 states for. There's an idle state, a walk state, and a run state. Once you have those created, basically all you have to do is trigger the states from your application to create some animation. And you can see that this one right off of the bat, my character is already in the idle state. The idle state is animated as is. And what I've done is hook up my keyboard to this. So I don't have any transitional states applied to this. Silverlight or Blend 4 gives you the option of creating transitional animations between your visual states. But in this case, if I push my left key, he'll walk over to the left. If I push the right key, he'll walk over to the right. The thing you want to notice here is that the state that's listed up in the top left in either case is the same. It's walk. It's not walk left and walk right. And the way that I handled that is the actual animation has the character walking to the right. And when I want him to walk to the left, I just scale it -1 along the x-axis, and it flips the entire action for me. And then the other thing I have is a run action. So I have the option of making the character run in either direction as well. So that wraps it up on the frame-based animation techniques. I'm going to close out the session today with a discussion about kinematics. Kinematics is about how things move. It's actually used pretty extensively in 3D animation for articulated objects or constrained joints. And there's a lot of really cool stuff you can do with kinematics on the procedural end. Conceptually, what we're talking about is establishing a chain of objects where an object's rotation and position is based on the rotation and position of the object that's next to it. And when we're talking about kinematics, we have 2 different ways that we can approach kinematics. There are forward kinematic chains, in which the first object determines the position of the other objects in the chain. And then there are inverse kinematic chains. And the inverse kinematic chain, the last object's position and rotation, propagates up the object chain. And if you want a way to think about this in terms you will probably understand pretty easily, is if you think about your leg, if I ask you lift up your thigh, you're looking at a forward kinematic chain as your thigh is driving your calf and your foot lifting up off the floor. The inverse of that is if your foot is up off the floor and somebody were to come and grab your foot and pull on it, or I ask you to lift your foot up, it's going to force your calf and thigh to come up after as well. So you can look at your leg as a chain that heads in either direction. A basic example of a forward kinematic chain would look something like this. Basically what you're looking at in the top left there is the kinematic segment that I used to create this animation. The overall length of my segment is 155 pixels, but what's important is the actual segment length from pivot to pivot is 120 pixels. What I've got is I've established 2 forward kinematic chains. Segment 0 to segment 1 is one kinematic chain. Segment 2 to segment 3 is another kinematic chain. And when I referred to constraints on the kinematics before, I can constrain my movement angles at different pivot points. The blue ellipse here indicates a thigh constraint. The green indicates a calf constraint. And in this case, the thing to keep in mind here is that the thighs are driving the calves. This is what the code behind a procedural walk cycle looks like, a forward kinematic chain. I have a method here called move segments that I'm passing the 2 segments that make up a chain in. If you remember, each leg is made up of segment 0, segment 1, or segment 2 and segment 3 create a leg. And then a cycle, which is actually an angle, which gives me a rotation angle. The important thing, when you're looking at this, is a lot of overwhelming math that's going on here, but the important thing to take away from this is that you're looking at basically 7 lines of code that create a procedural walk cycle, and there's numerous points that you can latch into this to give user control or allow a slider to manipulate the values that are running within the animation. So here's a demo, the end result of what that code actually will do for you. So there's 7 lines of code creating a procedural walk cycle for me. I have an option here. I can adjust the speed up to actually a pretty rapid pace if I wanted to. Alternatively, I could drop it backwards and have it run in reverse. My thigh constraints, if I'm dropping my angle on this, you can see that they become a tighter movement. If I want a broader stride, I can stretch it out a little bit and get more of a running motion. And then I also have the same option to do with the calf constraint, where they can become very stiff and immobile or even move in reverse. So you can see when it's actually running in reverse, I think it looks a little bit more like arms than it does legs. The other type of chain I talked about was an inverse kinematic chain. In this case, what you're looking at is something that's supposed to emulate kind of a bicycle chain without the sprockets. In this case, it's a single inverse kinematic chain that's made up of 25 segments. Again, at the top left, you're seeing the kinematic segment. In this case, the overall width is 150 pixels, but the length, again, is important, where I have from pivot to pivot is 65. The end of this chain is out here. The beginning of the chain is down here. And the way that the inverse kinematic chain works is that the position and rotation of my 25th segment controls the 24th. The 24th one controls number 23, and it just kind of keeps going all the way up the chain. So the code for this one is a little bit more complex because I have to make two different moves on this one. Here's the code that creates an inverse kinematic chain for me. The first method you're looking at, reach, is past the last item in the chain, and basically is positioned as it's reaching for the mouse. And then down on the bottom, the simpler method, position, runs through each set of segments within the chain in pairs and positions each one associated with the one next to it. And again, the important thing here is even down on the position side, you're only looking at 3 lines of code there. And the end result that you're going to get is an inverse kinematic chain that basically reaches for the mouse. And the way that the positioning and angle is handled is such that if I just move the mouse a little bit, it's only going to affect a couple of the links on the chain, whereas if I'm making broader movements, it's going to go ahead and create potentially a snaking action or whatever it is you happen to attach your reaching motion for. So that kind of wraps up what I have for you on animation. I want to thank everybody for coming by today. If you're interested, on the download link that's listed there, my book has over 180 projects in it. A lot of the concepts here are taken from that. If you go to that website, you can download all the projects from the book and play with them. If you want to learn more about how something works, feel free to grab a copy of the book. I need to ask you to please, if you get the opportunity, take a moment to fill out your session eval. I like getting the feedback and hearing what people have to say. If you have further questions that you come up with later, my contact information is up there on the screen. And what I'd like to do now is spend a couple minutes taking questions. And for the first couple of people that send me softball questions, I have copies of my book. Thanks. Go ahead.
Hey, Jeff. So I know in Blend, normally when you go in and you create a storyboard, all the things that are in that storyboard or all the sub-animations are targeted at a named element. So if I wanted to, like make a game engine where I could use a tool like Blend to create an animation, but then instantiate that, right? So it's like a tool to create a template, but then create instances of them as I need them. Is there a nice way to do that?
I think if I was approaching that particular problem, I would just go procedural with it. The problem is that when you're targeting a particular object, the procedural animation is kind of locked up, and if you inadvertently try and basically reuse that storyboard and point it at another object while it's already running, you'll end up getting an exception. So it might be a better approach to create the procedural animations kind of on demand and do it all from code rather than rely on one or two or a series of storyboards in XAML, which will probably end up getting kind of lengthy anyways. You're probably better off using reusable code there. Okay. If you want to come up, I can get a copy. Let's go over here.
Yeah, we use the Bing map control quite a bit, and I'm wondering if you've had any experience animating objects on the Bing map control, if that's doable, like a canvas kind of thing.
On a Bing map control?
Yeah.
I haven't come across any projects where I've needed to do that in particular. I think that the initial approach that I would take on that would be to consider laying a canvas maybe up over the top and doing my animation. One of the nice things about the Bing maps is the information that you get back for it. A lot of that is, what I would rely on probably in an animation would be latitude and longitude if I was doing something like maybe a flight tracker or something. So I think I think you could approach that one of two ways. You could show the entire map and have something moving across the map, or you could focus in on where that object was and move the map up underneath it. So I think in either case, I would probably do a layer up over the top and put my object up in there.
Okay.
Does that help? All right. There you go. And thank you. Enjoy.
So you didn't talk at all about the composition target rendering and the way to actually do animations through that. Is there a reason why you chose the? Okay.
No, there's actually three. So there's three different ways of approaching it. I thought from the declarative side, it's a little bit easier just to talk about empty storyboards. Okay. So you have the option of using storyboards with duration of 0. You can use a dispatch timer, which is reliant upon the system time to pass time in your application, and then composition target rendering, which is reliant upon the refresh rate inside of your browser. One thing to keep in mind if you're using composition target rendering is when your application is out of view, if you scroll down in the browser window, it stops running. So it only runs while it's in view. Okay. But performance-wise, composition target is the fastest. Dispatch and storyboard, based on the tests I've seen, are actually pretty similar.
Okay. All right. Thanks.
Anybody else? All right. Thank you.